All right, well, let's go ahead and get started. Thank you so much for joining us. This is a part of a monthly professional learning series for the ACESSE project and UW STEM Teaching Tools collection. My name is Jeanne Norris, and I'm sort of leading these monthly sessions. Again, it's based on STEM teaching tools developed through the ACESSE project. There will be future opportunities, so we are very excited to share those with you. Be on the lookout for them via Twitter and your email networks. These webinars will be recorded on their respective session pages. So our STEM Teaching Tools website has a PD tab, and whatever session you're looking for, you can click on that session and you'll find the recording when it exists. So really hope to see you at these future opportunities and look forward to your feedback on them. All right. So I'm going to turn it over to Bill. I don't think we have Christy yet, or do we?
Christy was here briefly, but I'll get us started. So I'm here. My name is Bill Penuel, and I'm at the University of Colorado Boulder. I am one of the co-principal investigators for the ACESSE project, which is producing these resources for educators and teacher educators. And the purpose of this series is to build capacity around the open tool collection that's part of ACESSE. All of the modules, including this one, have been co-designed by science education researchers and members of the Council of State Science Supervisors, the professional association that brings together the leaders in science education in all 50 states, the District of Columbia, and 4 US territories, as part of the ACESSE project, which is an NSF-funded project. You may, as a first thing to say, you may use and adapt any part of these with educators that you work with in whatever form that you would like. These are Creative Commons license, and what that means is that they are free to be used and adapted as you see fit for your purposes. I'm not sure Christy's.
Christy. Yep, I was able to hop on. I don't know. I had some technical difficulties this morning. Sorry about that. Thank you for joining us. I'm Christy Krenek. I was part of the Council of State Supervisors. Now I'm with Santa Fe Public Schools as an educator. Thank you for joining us, and thanks, Bill and Jeanne, for taking the reins while I was struggling to get in.
You want to lead us in this first one? There we go.
Absolutely. So the purpose of the, our webinars is just to give people a set of tools as you run professional development in your community, your school, your context. And this workshop, we really focused on looking at student interest and the community priorities of selecting purposeful phenomena as anchors, and how that would tie into looking at scenarios that could be also used with the tools for assessment. We really encourage that if educators have not been through resource E on phenomena or have a solid footing of what is phenomena, that this not be utilized first. It's just going to cause a lot of frustration. I experienced this already running this tool with some educators that did not have that background. And so we want to just put that out there for the community to really think about who your audience is. And this sets a set of tools to support them and their journey with storylines and NGSS, three-dimensional teaching and learning.
So we want to begin today with land acknowledgement, to acknowledge that we are all, wherever we sit, on native land. And I am coming to you from the lands of the Arapaho, the Cheyenne, and the Ute peoples, as well as 48 contemporary tribal nations known as modern-day Colorado. We offer a land acknowledgement to highlight our commitment to supporting Indigenous presence in our science classrooms. And you'll see that presence and examples of phenomena that we're going to be sharing today. And at this website that I'll put in the chat here, you can actually find where you are if you've never explored this before. And feel free to do as Jeanne did and add where you are here on Turtle Island.
Thank you, Bill. All right, so we're going to do some introductions. So in the chat, if you could please let us know your name, your location, and your role in science education. And so we'll wait for some of those to roll in. But just a couple of housekeeping things. Please feel free to meet your needs as they arise during this session. I want to say thank you so much for showing up on a Saturday. I know that that's a big ask because free time is precious when you're an educator, so thank you. You can access the slides here, and I'll put them in the chat in just a second. And then there's the base resource that was developed by Bill, Christy, and their team thanks, Bill, putting those in the chat right now. So again, these are all housed on our STEM Teaching Tools website, all of our sessions. So if you're looking for the previous sessions that they're going to sort of let you know might be like a prerequisite for this session, you'll be able to find those on the same website.
Yeah, so two brief things before we jump in. As Christy said, it's really important to frame this particular resource. And what we would hope is that people come to this workshop with a foundational understanding, at least, of what phenomena are and their importance to the vision of the framework. And a whole process for selecting phenomena for teaching is an already published resource called Resource E. You can actually use this one and insert it into Resource E at a specified place where the facilitator guide helps you. This resource addresses a very specific need identified that was not addressed in Resource E, which is the need for a variety of phenomena in teaching and learning. And then as we move forward for the next hour or so until we step out and think about this resource as potential facilitators of it, we want to invite you to participate in Learner Hat. And what that means is, imagine if you're somebody who's going to lead this activity, participate as somebody that you might encounter in a professional learning workshop where you are leading this. You may also be just here to learn about different kinds of phenomena, so you're already showing up as an adult learner. And either way, we just invite you to show up that way, as opposed to someone who is looking at the design from the standpoint of somebody who is going to just right out of the bat, lead it. Hold those questions. There'll be time for you to reflect with others here if you are a facilitator of professional learning and want to use this in that way, to reflect on it in that way. And I think I'm turning it back over to Christy.
Yes, thank you, Bill. So we just wanted to kind of go over some of our goals and objectives for our session. And we're going to give you some time to work together because we know collaboration is always very valuable and important. So we're going to go ahead and brainstorm some considerations about what makes meaningful phenomena for students, and of course the importance of why we do that. We're going to provide some phenomena descriptors generated by the Council of State Supervisors, with Bill leading us with that work, and which ones may or may not be compelling. And we know, as the people in the room, that you have your own local context, so hopefully this will be a guide to help you support developing out your own. And of course, looking and exploring some framework for examples for different classes of phenomena as we utilize those moving forward. And so we look at the importance of why we're doing this work. And it always goes back to the framework and the major goal of science education. And in that, it is to provide opportunities for students to connect to their personal and their community as they make their way and understand the world around them. One way that we do this is accomplished through the use of phenomena investigations. And now that we have a working definition of phenomena throughout the community, it is important to look at how to expand that. And the time it takes to build phenomena, we understand, can be time consuming. And we really need to think again about the interest of our students and engaging them in the learning process. So this is one of many resources within the STEM teaching tool suite to support this, this PG module. But here's a few others that you may want to consider, and I see they'll probably be dropped in the chat, is STEM Teaching Tool 31, 57, 58, and 69 as you go through this journey. Okay, and so at this point, we're going to go ahead and have our first discussion pieces, and we have a couple guiding questions for our group. And what are some of those qualities of phenomena that make them compelling to students is our first ask. And then of all phenomena likely to be compelling for students. And so we think about that. And then if not, what can we do to ensure that they're equitable and just in our selection of phenomena? So I'm going to go ahead and have you think about this. And then when you're ready, go ahead and, put some ideas into the chat to share out with the group. Thanks, Jen, for getting us started. And, if students can relate to the experience and creating those common experiences with it. That's very important, seeing ourselves in the people who are participating in the learning. Absolutely. Complex and truly allow for sense making, real world application to science, relatable, relevant to their lives right now. I love seeing these, keep them coming. It's very exciting to see what our community has to offer. Very good point. It should be something that they work with, not just a hook. So really, acknowledging this is, something they work with directly over time, not just kind of a one and done. And as we continue through, feel free to continue to drop some ideas around these two questions. These are definitely going to be kind of how we frame our time together. At this point, I'm going to go ahead and pass it back to Bill.
Thanks, Christy. So we're going to actually give you a little bit of individual think time in reviewing a set of descriptions of about 15 different phenomena that our team came up with, where these also reflect different local places. So everyone on the team generated teams that reflected phenomena that were close to them. And one of the things that I think is I think someone put in the chat, it's like you can't really have a phenomenon that is compelling to everyone. And so the idea is to think about a suite or set of phenomena that might be compelling to students. And we want to really center the experiences of those students who have been most excluded from science and engineering. And in reviewing these, what I'm going to ask everyone to do is to think about your own classroom context, and you'll have a chance to discuss your selections and also the selections of the group in small groups in a bit. So you might even think about one or two students that you've taught that you would pick these for them. And what are some of the changes that you might also make in order to make them more compelling to students in your classroom? We don't assume that these are the given, these are going to be workable as is. However, I will say this, and you can go on to the next slide. One of the things that we were very careful about is in framing questions. And for those of you who are thinking about, for example, writing new units that are anchored in phenomena or developing assessments that are anchored in phenomena, the way that you phrase the question really matters to help focus student curiosity in a direction that helps them take up the focal science ideas and also other important local knowledge. The way that that question is worded is mattered for whether it sparks curiosity as well. These are very brief descriptions of phenomena, usually a sentence or two, no more, and then a question to focus the inquiry. And you'll see that in each of these descriptions. And let's see, what I'm going to do is pop a poll in the chat that you're going to fill out as you read these. So you'll want to have access to the slides at this point because you'll have the invitation to go through, and maybe we can put that link in the chat again. So you'll want to have access to the slides, And you'll go through each of these and you're going to select 4 of these to vote on that you think would be most compelling to students most excluded from science in your area of the world. And we'll spend about 15 minutes in this activity. So I'll keep a little time and maybe put a little music in the background. And then we'll put you into some small groups to discuss your selections and talk about why you picked what you did. What do these, and this is just for everyone, what, if anything, do these phenomena seem to have in common? I know at least one group that I visited talked about this. So there is a human and social connection in all of these, huh? Yeah. What else? So I'm going to turn it over to Jeanne, who'll talk a little bit about some of the commonalities and differences that we designed for in this classes of phenomena.
Awesome. Okay. And I'm going to share my screen again. Give me a second to just transition back. We're good. We're sharing the screen how it should look. All good? Okay. And if you notice in the chat, I just added a spreadsheet where I've been crowdsourcing local examples of phenomena by state. So you can look at your own state, look at other states to find exciting phenomena too. All right. So one way to characterize the variety of phenomena we've looked at today are these 4 classes. And these are examples of phenomena that highlight the ways that science is a human cultural endeavor. So science is a set of human practices for making sense of the world around us. And these classes are also reinforcing the idea that people are a part of nature, as Bill had mentioned. That is, we shape and are shaped by phenomena. So the 4 broad kinds of phenomena, I'll let you take a look really quick, are everyday, contemporary scientific, societally relevant, and culturally relevant for specific groups. And this is based on work from Enrique Suarez and Philip Bell. So all of these phenomena embody characteristics of phenomena that we identified earlier. They pertain to an observable event that we can use our science ideas and practices to explain. And here's what makes these phenomena different from one another, but they're still helpful in thinking about what could make phenomena compelling. So we have everyday phenomena, which are complex phenomena that all students will be able to experience in class or have experienced outside of class. We have contemporary scientific that relate to current science, most often science that is in the news today because it's unsettled or sparks controversy. We have societally relevant phenomena that relate to science technology intersections and connecting care and concern and enabling students to see connections to social and socio-ecological justice. And we have culturally relevant for specific groups. So this is grounded in the worlds of specific communities and allows students to draw on ways of knowing from families and cultural communities. And this has social importance for communities. Oops. All right, so let's go through an example of each of these in depth. So here we have a squirrel that is interacting way too closely with a human for my comfort, but let's see what we can think about this. So in certain cities, squirrels are common, for example, in Colorado, and some of them get very bold, coming right up to people. So how do squirrels and other city animals differ from animals outside of the city? That's a question that we could ask about this everyday phenomenon. So this particular phenomenon has the potential to address high school LS 4-3, which is all about applying statistics and probability to support explanations that organisms with an advantageous heritable trait tend to increase in proportion to organisms that lack this trait. So this is so because scientists have found that in some populations, organisms become less stressed out when encountering humans due to lower levels of cortisol in their blood. Those organisms with less cortisol survive to reproduce because they're able to access food that humans leave behind. So this would be an example of an everyday phenomenon. So next up, we have contemporary. So the example here is from, you might recognize this picture. It is CRISPR. So scientists have discovered that a defense mechanism of bacteria against viruses can be used to help cure diseases by editing genes. The question is, should this be used? What are the issues and consequences of editing genes to cure diseases? So those are two questions that you might ask about this particular phenomenon. So this phenomenon can address the nature of science aspect, as you can imagine, of the following performance expectation, high school LS 3-3, which is all about applying statistics and probability to explain the variation and distribution of expressed traits in a population. So that nature of science dimension emphasizes science as a human endeavor, and this phenomenon would allow students to grapple with the ideas that technological advances have influenced the progress of science, and science has influenced advances in technology, as well as science and engineering influencing society and society influencing science and engineering. So they can also apply that knowledge of genetics and genetically based diseases to explain how gene editing tools like CRISPR work. And we can really think about, you know, as Colleen said, like add the questions, who gets to answer these questions and will everyone benefit equally? Lots of ethics that we can talk about with this for sure. Thank you. Oops. Okay, so the next example is societally relevant. So since 1955, the percentage change in snowpack in Colorado's mountains has dropped in most places. This is significant since most Coloradans and people living in states downriver get their water from that melting snow every year. So a question we might ask is, how might reduced snowpack affect human populations that depend on water from Colorado's mountains? And, you know, the phenomenon can also include this data chart like we're showing here, right? So climate change is very societally relevant with locally important implications. So this phenomenon would require students to understand the causes of climate change, model potential future impacts, and you can see connections to high school ESS 3-6, for example, using computational representations to illustrate that relationship between Earth systems and how those relationships are being modified due to human activity, as well as ESS 3-1, about natural resources and their availability and natural hazards and how changes in climate have influenced human activity. So many culturally relevant or societally relevant examples here. And then next up, we have culturally significant. So in southern Colorado, Mexican and Spanish farmers introduced a communal irrigation system called ACESSE that had been used since the mid-1800s to divert water from natural streams from nearby canyons to irrigate long plots of farm and grazing land. The ACESSE system allows each landowner equal access to water. So how might drought and development threaten this system? That might be a question that we might ask about that phenomenon. So this is a cultural system for sharing scarce water resources in a dry area. And that's another example of the potential impact of climate change on human activity, which could impact culturally significant practices. So it can relate directly to the standard high school ESS 3-1, again, thinking about that availability of natural resources, occurrence of natural hazards, and changes in climate that have influenced human activity. And so I think from here, I'm going to shift it back to Bill.
That's great. So I just wanted to have a really kind of brief discussion before we give you a little bit of a chance to engage with two of the designers, Christy and me, with specific questions that you might have and some groups. But wondering if we kind of go back to our first question, which is, can phenomena be compelling to everyone? Like, how might this actually help us, specifically with students who are excluded from science and engineering? If anyone wants to offer either out loud a thought on that or in chat too. We can come back to the question about the local that's happening, the rich discussion on local that's happening in the chat. Thoughts about how this concept of classes of phenomena can help us with this problem. No matter what the phenomenon is, we have to build some common understanding often of the phenomenon itself. And the farther away it is from our scene, then we want to generate questions from kids that will help them like actually figure out the stuff that they need to know, even to make sense of the phenomena. I mean, that's actually being really consistent with what the standards are asking us to do, which is, I have this really strange thing. I don't know anything about it. What are the questions that we need to answer in order to start to make sense of this thing together? And that's really a great way to launch a unit, in fact, to do that. I wanted to address really just one nuanced take, hopefully, on the idea of local being culturally based. I would say that everything in some sense is cultural, but the lens that we bring onto place really depends on our own cultural location, if that makes sense, right? So we could have a local phenomenon that kids from a particular cultural vantage point don't resonate with because of how we've presented the place, right? So do we present, I mean, we just had a lovely exchange about, well, what are the origins of the Asakias? If I presented that as, hey, this is this contemporary thing that was just invented in 100 years, and then I added, maybe what if I presented it that it's from, as I did in the chat, Hispano-Colorado culture, so been here 300 years, or as Cecilia shared, actually, there's an indigenous history to this. So how we present the local is itself culturally, and some of our kids might feel excluded by how we're talking about the local, and other people will might feel included by representing the longer arc of history of place in particular. Megan Bang reminds us to think about multiple time scales of history when we think about a place. So if we're doing place-based, one of the ways that we can make sure that we're being equitable about that is to really think about this place over long time scales, and make sure we're being purposeful about representing that. Thanks, Adrian. Like thinking about this intentionality. Yes, and no single phenomenon is going to work. So we can go to the next slide, and I would just invite people to pop out of Learner Hat and think just for a few minutes to see if you, just what stands out to you about this resource, and now thinking about yourself potentially as using this with other folks. What stands out to you, and how might it help people deepen their understandings of how to select meaningful phenomena? And I want to point out that Resource E has people in selecting phenomena use a student interest survey. I know it came up earlier in one of the kind of small groups I think I was in, I think it was that we in Open SciEd, putting on my Open SciEd hat for a moment, we actually give interest surveys. And we're always struck as writers by how hard it is to actually guess which ones are going to win. And to this point about the local, the things that are like kids in Colorado are equally interested in oysters dying off as kids in Michigan and the Pacific Northwest. And that's a little mind-blowing to think about. Like the way you present the phenomena can actually captivate kids in ways that aren't limited to their place. So it's really interesting to think about checking ourselves as you invited us to do, Adrian. So. Oh, the 2019 source, Julie, maybe we can send this out afterwards. I think there's a version of it that lives in somewhere in our Google ecosystem, Jeannie. So, but I'm not sure I could find it too. Oh, there's another resource. Thank you, Jeannie. Yeah. What other ways might this resource be useful that you're thinking about? Yeah, so really having the opportunity to experience this, this group is also, team was also working on a resource that we're developing around. So I have a compelling phenomenon, what do I do next? And a lot of that will be to bring people in, experience and student hat, as we like to say, so that they get to experience as a learner. I think I want to maybe, Jeannie, move us along to being able to do some self-selected breakouts. And so Christy and I are going to split up. And so we want to allow folks who just want to have some kind of time to reflect and ask questions with us. So if you're in group A, you would self-select, we'll set up the breakout so you can just go to the room you want to go to. So you have a group that you want to use it with and lead it, and you want to interact with the developer and just talk to us about it. And so we'll just come for a few, we'll take about 8 minutes, and then we'll come back to the main room right at the end and just close up. And group B would be, and also Jeannie has just put in a survey at the end. So if you do have to leave before we come back to the main room, please fill that out. We really appreciate your feedback. Group B is, I'm not sure when I would use this, but I'd like some time to reflect on or ask questions with others for a developer. So we just wanted to give time in a couple of smaller groups to be able to interact with us around the resource. All right, Jeannie, I think we're ready when you are.
Yes, room 1 will be group A and room 2 will be group B. Okay. And yeah, I did put the link in the chat. So if we did need to close out, like just in the groups, because we're just having such great discussions, we can do that. I just really would appreciate your feedback. But yeah, I'm going to open the rooms now. Thank you. Well, I'm going to just resume the recording really quickly and just say thank you to everyone. Please do fill out the survey if you can. We have many resources like the ones that Bill, Christy, and I shared on our website, stemteachingtools.org. You can find us on Twitter at STEMTeachTools. We have a lot of great discussions on there. And please look for our other Access OER PD modules, like the ones that are prerequisites for this session, by visiting our website at stemteachingtools.org/PD. Bill's contact information is here for you if you would like to contact him further. And other than that, that's all I have. So thank you so much for coming on a Saturday and joining us. We're happy to stay on longer and continue that rich discussion you were having in small group. Thank you.